Welcome to Spring Lib.
We want to write a formula for the piecewise function whose graph is shown. So let's say our function is f of x and that there are three pieces to this function. The first piece, let's first give the intervals for where the pieces exist. So notice this first piece goes from negative infinity, because I'm assuming that this goes on forever, and then until -1 and it's open. So we would say from x is, for the first piece, when x is less than -1. And the second piece is from -1 to 1. So x is in between -1 and 1, where it's included at the -1 and not at the +1. And then the third piece is from an x value of 1 and then forever. So we would just say greater than or equal to 1. Now the first piece is a linear function. It has a slope of -1. It goes down 1 over 1. And its y-intercept would be at -3. So it's -x minus 3. You can test it out if you're ever not sure. Like when x is -3, it should be 0. So negative of -3, which is 3 minus 3 is 0. The next piece, the second piece, is a constant. Constants are just a y equals, or f of x equals 2. And then the third piece is a quadratic. This quadratic has a vertex at 3, 5. So we could first write it as x minus 3 squared plus 5. That takes it to 3, 5. And when we go over 1, we're going down 2. And normally we're supposed to be going down 1, because from the axis of symmetry, 1 unit from the axis should be a vertical change of 1. 2 should be a vertical change of 4, but then that's 8. This tells us there's a vertical stretch here of 2. And it's upside down, so there should be a negative. We could test here, like it appears that 4, 3 is on that function. If x is 4, 4 minus 3 is 1 squared is 1, times -2 is -2, plus 5 is 3. That checks out. Let's multiply this out. This would be -2 times x minus 3 squared is x squared minus 6x plus 9. And then distribute the -2, we get -2x squared plus 12x minus 18 plus 5. So it'd be -2x squared plus 12x minus 13.